In this video, we're going to solve the following related rates problem. A man walks along a straight path at a speed of 4 feet per second. A spotlight is located on the ground 20 feet from the path and is kept focused on the man. At what rate is the spotlight rotating when the man is 15 feet from the point on the path closest to the light? So let's start by drawing a diagram. So we have a straight path, and let's say this is the path that the man is walking on, and we have that a spotlight is located on the ground 20 feet from the path. So let's say here's the spotlight. Which means that this distance here is 20 feet. And let's say the man is over here, and we'll label this distance x. So x will be the distance from the man. So I'll write x equals distance from the man to basically the point on the path that's closest to the spotlight. Okay, great. Now, we know that the spotlight is following the man, so we have some sort of line here, and we can call the angle at which it moves theta. Okay, so what information are we given? Well, we're given the rate at which the man walks along the straight path. He's walking at a rate of 4 feet per second. So that means that dx dt equals 4 feet per second. Okay, now what is it we're being asked to find? Well, we're being asked to find at what rate is the spotlight rotating when the man is 15 feet from the point on the path closest to the light. So that means we're being asked to find d theta dt when x equals 15 feet. Okay, so can we think of an equation that relates x and theta? Well, if you remember from trig, you have SOHCAHTOA, right? So if we have theta here, we have opposite over adjacent. So this tells me that opposite over adjacent, x over 20 equals tan of theta. So this is an equation that relates x to theta. Now I want x on its side by itself, so I can just multiply both sides by 20, and I get x equals 20 times tan of theta. Great. Now I can differentiate both sides with respect to t and get the following. The left-hand side just becomes dx dt, and then the right-hand side becomes 20 times the derivative of tan of theta, which is secant squared theta times d theta dt. Okay, and so remember, we want to solve for d theta dt when x equals 15. So first, let's isolate that. So I'm going to divide both sides by 20 secant squared. So we get 1 over 20 secant squared theta times dx dt equals d theta dt. Now, we know that 1 over secant squared theta is equal to cosine squared theta. So I can rewrite this as 1 over 20 times cosine squared theta times dx dt equals d theta dt. And remember, we want to solve for d theta dt when x equals 15. And we know that dx dt from above is 4 feet per second. And we don't know what theta is yet, but we can solve for that. So first, let's plug in everything we know. So this becomes 1 over 20 cosine squared theta times 4. Okay, now what's going on when x equals 15? Well, we have that the length of the beam, which we can calculate, right? Because we have this right triangle. So when x equals 15, we have that 20 squared plus 15 squared equals 25 squared. So this length here is 25 feet. And now we can use that to find cosine, which is adjacent over hypotenuse. So that tells me that cosine of theta is equal to opposite, which is 15, over hypotenuse, which is 25. Oops, sorry, adjacent over hypotenuse. Adjacent is 20. So we have 20 over 25, and that is equal to 4/5. So if we plug that in for cosine of theta, we get 1 over 20 times 4/5 squared times 4. So this is, let's see, 16 over 125. So this is d theta dt when x equals 15. So again, what does this mean? This means that the spotlight is rotating at a rate of, now we, I guess, want to write our answer in terms of radians per second. So maybe we do that quickly over here. So this is what we have. We have that this is approximately 0.128. So if we wanted to write our answer in terms of radians per second, we have 0.128 radians per second times 1 rotation over 2 pi radians times 60 seconds over 1 minute. And so if we multiply all that, we get that that's about 1.22 rotations per minute. So the spotlight is rotating at a rate of 0.128 radians per second, or you can say 1.22 rotations per minute. And this is the final answer. So let's do a quick recap of what we did. So first, we drew a diagram and we labeled the variables and the information we knew. We then came up with an equation that related these two variables and we differentiated both sides with respect to t, and then took the information we were given to solve for the information we wanted to. And by plugging all that information in, we were able to get the answer. If this video was helpful, feel free to like and subscribe.